Alright, so in this problem, I have 6 to the power of 100 minus 6 to the power of 97. So, now the first thing I'm going to do is I'm going to rewrite 100 here as 97 plus 3. So now I have 6 to the power of 97 plus 3 minus 6 to the power of 97. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times, a to the power of m times a to the power of n. So in this case, 6 to the power of 97 plus 3, I can rewrite as 6 to the power of 97 times 6 to the power of 3. Now I have this minus 6 to the power of 97. Now from here, if I factor out 6 to the power of 97, I get 6 to the power of 97 times, now 6 to the power of 97 divided by 6 to the power of 97, 6 to the power of 97 times 6 to the power of 3 divided by 6 to the power of 97. All that's going to be left is 6 to the power of 3, and negative 6 to the power of 97 divided by 6 to the power of 97 is negative 1. So I have 6 to the power of 97 times 6 to the power of 3 minus 1. And now 6 to the power of 3, well, 6 to the power of 2, that's equal to 36, and 36 times 6, that's equal to 216. So I have 6 to the power of 97 times 216 minus 1. And 216 minus 1, that's equal to 215. So now I have 6 to the power of 97 times 215. So my answer is 6 to the power of 97 times 215. Now I actually have a second method of solving this problem. So I start with 6 to the power of 100 minus 6 to the power of 97. Now this time, instead of rewriting 100 as 97 plus 3, I'm going to rewrite 97 as 100 minus 3. So now I have 6 to the power of 100 minus 6 to the power of 100 minus 3. Now I'm going to rewrite 100 minus 3 as 100 plus negative 3. So now this is going to be the same thing as 6 to the power of 100 times 6 to the power of negative 3. Now from here, if I factor out 6 to the power of 100, I get 6 to the power of 100 times 1 minus 6 to the power of negative 3. And 6 to the power of negative 3, that's the same thing as 1 over 6 to the power of 3. Now remember, 6 to the power of 3, that's going to equal 216. So now I have 6 to the power of 100 times 1 minus 1 over 216. And 1 minus 1 over 216, that's equal to 215 over 216. So 6 to the power of 100 times 215 over 216 is another way to write our answer. Alright, so in this problem, I have x to the power of x to the power of 4 is equal to 64. So now the first thing I'm going to do is I'm going to take the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is simply equal to a to the power of m times n. And m and n, you can actually switch the places of these two. So this is the same thing as a to the power of n times m. Now, if I can write something in the form a to the power of m times n as a to the power of m to the power of n, this means that I can write a to the power of n times m as a to the power of n to the power of m. So we can think of x to the power of 4 as m in this case, and 4 as n. So if a to the power of m to the power of n is equal to a to the power of n to the power of m, then x to the power of x to the power of 4 to the power of 4, that's going to equal x to the power of 4 to the power of x to the power of 4. And this is equal to 64 to the power of 4. Now, 64, that's the same thing as 8 to the power of 2. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 2 to the power of 4. Now remember, if I have something in the form a to the power of m to the power of n, that's equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4. And 2 times 4 is 8. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 8. So now I'm going to let x to the power of 4 equal to the variable y. So now I have y to the power of y is equal to 8 to the power of 8. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b as long as b is greater than or equal to 1. So in this case, b is equal to 8, which is greater than or equal to 1, meaning y is equal to 8. So now remember how we let x to the power of 4 equal to y, meaning if y equals 8, then that means that x to the power of 4 is equal to 8. So now to solve this, I'm going to take the fourth root on both sides. Fourth root of x to the power of 4 is x, so I have x is equal to the fourth root of 8. So this is my answer. Alright, so in this problem, I have 2 to the power of 20 minus 1. So I'm going to first start by rewriting the exponent 20 here as 10 times 2. So now I have 2 to the power of 10 times 2 minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, 2 to the power of 10 times 2, I'm going to write as 2 to the power of 10 to the power of 2. And I have this minus 1. Now 1 here, this is the same thing as 1 squared. So now I have 2 to the power of 10 to the power of 2 minus 1 to the power of 2. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to 2 to the power of 10 and b is equal to 1. So now I have 2 to the power of 10 plus 1 times 2 to the power of 10 minus 1. Now 2 to the power of 10, that's equal to 1024. So now I have 1024 plus 1 times 1024 minus 1. Now 1024 plus 1, that's equal to 1025. And 1024 minus 1, that's equal to 1023. So now I'm going to rewrite these as 1000 plus 25 times 1000 plus 23. So now, to solve this, I'm going to distribute the 1000 first. So now I have 1000 times 1000, which is simply 1000 squared, plus 23 times 1000, which is 23,000. Now if I distribute the 25, I have 25 times 1000, which is 25,000, plus 25 times 23, which is equal to 575. So now I have 1000 squared plus 23,000 plus 25,000 plus 575. So now 1000 squared, that's equal to 1 million. So now I have 1 million plus 23,000 plus 25,000 plus 575. Now 23,000 plus 25,000, that's going to equal 48,000. And 48,000 plus 575 is 48,575. So now I have 1 million plus 48,575. And 1 million plus 48,575 is 1,048,575. So this is my answer.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 4 to the power of 3 plus 4 to the power of 3 plus 4 to the power of 3 plus 4 to the power of 3. Now what I'm first going to do is I'm going to factor out 4 to the power of 3 from this problem. So if I factor out 4 to the power of 3, I get 4 to the power of 3 times. Now 4 to the power of 3 divided by 4 to the power of 3 is simply 1, because anything divided by itself is 1. So same thing over here, 4 to the power of 3 divided by 4 to the power of 3 is 1. Same thing here, 1 and plus 1. So now we have 4 to the power of 3 times 1 plus 1 plus 1 plus 1. Now let's simplify what's in the parentheses. What's 1 plus 1 plus 1 plus 1? 4. So now we have 4 to the power of 3 times 4. And this is equal to, well, whenever we're multiplying an exponents, let's say we have a to the power of m times a to the power of n. This is equal to a to the power of m plus n. So we can think of 4 as 4 to the power of 1. So 4 to the power of 3 times 4 to the power of 1, this would equal 4 to the power of 3 plus 1. And 3 plus 1 is 4, so this would equal 4 to the power of 4. Now 4 to the power of 4 is the same thing as 4 times 4 times 4 times 4. So it's 4 times itself 4 times. Now 4 times 4 is 16. So this would equal, we have 16 here and 16 here. So 16 times 16, which is equal to 256. So this is our answer.